Welcome to another episode on my Raspberry Pi 2 running Ubuntu Linux with the robot operating system, which should control this breadboard with electronics and some Visitechnique motor with propeller, an LED and a phototransistor. It is connected to the Raspberry Pi with this grey band cable, and there is the Raspberry Pi itself with on top the Serial Pi Plus board connected to this serial cable, which is connected to minicom terminal. And right now the problem is that it was booting, and right here you can see a red LED, a bit small but it is there, and until a few moments ago the yellow LED, which signifies some action on the micro SD card which serves as a hard drive. Well, that LED was quite busy until now, but the minicom terminal does not show anything. So the question is, how is that possible? Well, without this I can't do anything. Oh, by the way, connected to the Raspberry Pi, which is so stacked under it, is also with this black cable to this monitor right here, which is currently standby because there's no signal coming to. But apart from that, everything should work. And the problem is, I can't, as I said, I can't see anything, so this won't work for now. How can I do things? Well, I can check to see if I need to select a different minicom connection, a different serial connection, and this has happened before. That for some reason the connection changed from 0 to 1 and 1 to 0. So, in order to verify that, I need to check something out. So let's try to do just that. Alright, as you can see, this is the desktop that you normally don't see except for this camera image and minicom terminal. Now this is T2 USB 1 and it's not doing anything at all. Here also the VNC viewer, in which usually using this address and this address are giving the two side panes with VNC with the Ubuntu desktop, but I have to concentrate on this one. So this was the first attempt. And lo and behold, yes, it has changed address. Not for the first time. So I have to log in. Alright, I'm there. I am for now ignoring the updates, and these are all the commands that I will use later on. Because I first want to start the VNC. If anyway possible. Yes, it has 1 and 2. This is 1, connect. which appears here, which I send over here. The second one, and this one comes over here, which is quite alright. And now I can reposition this one. I don't care. So this is basically it, kind of, more or less. So now I first have to make sure that everything runs, and in order to do that I start first the source code. And normally you don't see this because I set it up before I start recording, but in this case, because of this problem with minicom and the connection, I decided to do something, to do it in another way. Anyway, let me first go to the Catkin workspace root directory, then source the setup, not strictly necessary in this case, but I wanted to do it anyway. Then source RaspberryPi, and then again source and motor control and FT motor. Okay, so this is one, yes. And by the way, the tabs that you hear are literally hitting the tab key, because in Unix the tab key often means autocomplete. So if there's any command that can be auto-completed because there's only one command, fine, do it. If not, you have to find, you get choices and you can do more. And now new terminal, so I have to do the same thing. Source the development, and two tabs gives options to do. Two tabs and yes, source and two tabs. Okay, FT, and this is now this is tricky because which file is this anyway? I will find out soon enough, but let's just say okay, control FT control no. And see, this is a warning from VI. It says, oh, you already opened it, so quit. That means that I have to use motor. Oh, here I could have seen it because there's a swap file, which means this one has been opened already. Motor, and now it's alright. Then how to do things? Well, same thing basically. Go to the workspace, source, development, the setup, and now yeah, what to do? ROS run, indeed. I have to run the publisher. So basically oh, even more important, before I can run it, I really have to start ROS-core, which is not necessarily from this directory, but let me do it anyway. If things go right. That seems to be alright. So let's open the tab. And then I'll have to source once again. And now the thing is running the publisher. That will be this one, and then I presume this. Yep, there it goes. New window. And again I have to source it, and it seems to be maybe much work, but you'll have to source the environment in every window that you open. And now ROS run and then ft motor, which should be the, yep, it is. So now I have here the publisher running, and I have here the control running, the subscriber actually. So that's fine. However, I have not yet any of this running accessible, and that is via the GPIO. So now the question will be how to run it on the Raspberry Pi using C++ via the GPIO. That's the next step. Alright, so in order to get things with the GPIO done in C++, I come across this website, and I recall that back in the days when I was doing another experiment involving LEDs to be controlled from the Raspberry Pi GPIO, I used exactly the same thing, which is by now rather old, but it's still working. So I have, I have more than this. I do have a button, I do have some LEDs. More importantly, I have a Raspberry Pi. And then, using the terminal, I should be able to just say, alright, I write something to one particular port. Now the important is, of course, which port should I use? Should I use the GPIO or should I use the real port, the pin number actually? And let's view this one. This one is connected to GPIO 12. So then it would not be a very hard thing to do. And I say, okay, echo 1 to GPIO 12. And see whatever that makes. Is that a sudo action? Yes, because it has a bracket here, a hash, and a hash in Unix means root, and a $sign in Unix means user. In this case, I'm saying sudo echo quote 1 quote 2. Oh, only one, alright. And then hoping that this whole thing is there. Slash sys. And then class GPIO. GPIO 12 in my case. Dot slash value. Will this work? Ouch! Alright. So alright, this is working. So class yes, GPIO, which is working. Yes. Then I need GPIO 12. Right? Right. Or do I need some, do I overlook something? Ah, wait. Alright. But I need 4 and 17. So I need to go to do export. Echo 70. I need to do the whole step once again, of course. Not skipping ones. So, but this isn't that hard because I just say in this case echo 17, which needs to be GPIO export. Alright, that's one. Then echo out. Echo, yeah, it has to be output. Or the same thing, and then GPIO 12 direction. Yeah, GPIO and then GPIO 12 direction. And here we got a problem. Oh wait, I have made a mistake here. This should be not 11. Alright, 12. 12 direction. Now it works. Step by step again. And now I can go to this one. Except that it's not doing anything. So let me go right over here somewhere. pin out, pin out. Why doesn't it do it? So here is ground, this is 6, but I need to see these names. Okay, view image, no. Alright, this isn't working, not helping. So this is now a problem for the moment. This is wired to GPIO 12. Is it? I wonder. Oh, okay. 18 it is. My mistake. So I have to export 18. Then I have to echo out (18) and this to 18. Okay, I didn't expect this one. Now this one is burning. I can check if that is the right one. Yeah, most definitely. Alright. I was checking for this yellow wire, and instead I got one of these. So this means, and by the way, this yellow wire is in 18, GPIO 18, according to this one and to the pin counting. The fact that now 18 is another one means, simply put, that I have another numbering, which is out again. So yeah, I have to recalculate, review everything. Right, so using the schematics and using this image, which names every GPIO number according with the physical pin, I have now pin 12 for GPIO 18, pin 18 for GPIO 24, etc, etc, etc. So this gives a whole new point of view, and using this side, for which I found out that I had to use not the pin number but the GPIO number, I have to write a GPIO class. And now comes the question, don't I already have that? I should have that. I am right there. Now the question is, where do I have it? Not here, that is clear. So chances may be that I have it on my other Raspberry Pi, which is currently not powered up. And I have used that one also extensively for some very nice experiments. So I'll say I will save myself the trouble now of doing extra work. And conclude this episode. See if I can indeed copy the GPIO class into, because that is still a very big question. Let's go here as well. Where do I copy it? Where do I copy the class? Well, the class is usually a separate entity. So I will have to use the entity next to these two files, the publisher and the subscriber. And I can, oh, that's a nice thing, by the way. I should be able to do the red LED as well, but I trust that I will. Anyway, this is for the small green LED. On and off. More proof is not needed. That is going to work. Now I have to integrate it. And that for now is all of it. This way I should get everything to work. Will it work? That's another question. Right, and that's it for now. So, oh, I see that this one is out, but I'm not going to use it anyway for now. So a big change will be that I have to use the actual GPIO number instead of the PIN number. We'll see how that ends up. For now, thanks for watching. Been a while, but oh well, such is life. If you like this video, please subscribe to my channel, give the video a thumbs up, leave a comment or suggestion. You can also follow me via Instagram and via Twitter. And you can also support my blog by making a small donation or to become a patron and have your name mentioned as a supporter. More information via my website, and everything is under this video. Website URL, Twitter and Instagram names, and how to support and where to find information. Thanks for watching. This is of course to be continued, and bye bye.